Okay, so this is sort of continuation of yesterday's stuff. So as we look at the top of this, guys, are we going to use the product rule or the quotient rule? Both. We've got both going on here. So let's see here. Here's one function. Here's another function. They're being multiplied by each other. So we have the first function, which is x plus 1 over x plus 2 times the derivative of the second. What's the derivative of the second function? 2. I don't know what I'm doing here. Plus, there we go. The second function, which is 2x minus 5, times the derivative of the first. Ouch, yes, we have to do the thing, and we have to do the quotient rule, which you'll remember from yesterday is Booker T minus Taco Bueno over B squared. So we have the bottom, which is x plus 2, times the derivative of the top. What's the derivative of the top? 1 minus the top, so x plus 1, times the derivative of the bottom, which is 1, over the bottom squared. Now this is looking kind of crazy, and you guys have strong enough algebra skills that you could finish this off and it would be fine. This is one method. There is another way to do this. Your second option is you could say, okay, I'm going to rewrite the original function and see if I can't save some time here. This is actually 2x minus 5 over 1, yes? So let's multiply the tops. So you're foiling the tops. Do you see what I'm talking about? So the first terms are going to give you 2x squared. The outer and inner terms are going to get combined. So I have negative 5x and positive 2x. That's negative 3x. And the last terms are going to get you negative 5. And it's all over x plus 2. And now you can find the derivative of that. So now you just use the Taco Bueno rule, quotient rule. Bless you. So the bottom is x plus 2 times the derivative of the top. What is the derivative of the top? 4x minus 3, good. Minus the bottom, so, oops, top, just kidding. Sorry, I got confused. 2x squared minus 3x minus 5 times the derivative of the bottom, which is just a 1. And that's all over the bottom squared. All right, let's simplify. We're going to FOIL the stuff on the left. So I have 4x squared are my first terms. The outer and inner terms get combined, so I have 5x. And the last terms are minus 6. On the right-hand side, we're just multiplying by 1, so it's kind of like that 1 isn't even there. You just need to distribute the negative. Be very careful on the quiz you're about to take and make sure you are distributing the negative. I've only graded 5 quizzes so far, and I can tell you half of the people, did not distribute the negatives. So I don't know if that's a trend or if that's just the first 5 I've graded, but I would just watch that. So we have negative 2x squared plus 3x plus 5 all over x plus 2, the quantity squared. Okay, let's put our stuff together. 4x squared minus 2x squared is going to be 2x squared. So those are gone. 5x and 3x is 8x. And negative 6 and positive 5 is negative 1. Can you do anything else with this? Nah, we're good.
Will there ever be instances when you can factor the top and cancel stuff?
Good question. Yeah, you could do that. You could do that. Just like sometimes we take an X out of everything. I think that's happened a couple times in the last couple days. Yeah, same kind of deal. Yes, sir.
Can you explain the first step?
For this guy right here. So you're wanting to know where this came from? All I did was I did x plus 1 times 2x minus 5 over x plus 2 times 1. So I FOILed the top, and then the bottom was just x plus 2. So when you FOIL the top, that's what you get. Yes, ma'am?
What if you wanted to use the quotient rule on the first part, and then whatever you get for that, you use the product rule with the 2x minus 6 and you keep that.
Quotient rule. Well, that means you found the derivative of only half of it and not the other half. So if you are going derivative, you got to go all derivative.
Okay.
Good question, though. Logan?
Why did you get the 4x minus 3? Or, yeah.
Right here?
Yeah.
These guys? I
Or both.
I foiled this right here. Those two.
Where did you get the like, how did you get the
These two?
yes.
The Booker T Taco Bueno quotient rule. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Are you sure? No. Does this look familiar, Logan?
Yes, I get that. Just the differentiating in general.
Oh, okay. So, so we have bottom times the derivative of the top. 2 times 2 is 4, and then it becomes x to the first because you subtract off an exponent. And then there's a 1 here. 1 times 3 is 3. If I subtract off an exponent, that's x to the 0, so it's just a 1. You good now? Okay, yes, sir.
Is there an x plus 2 on the top and the bottom is x plus 2 squared? Could you cancel that before you...
Well, like right now. Like how there's one there and there's one there?
Yeah.
You could if there's also one over here.
Okay.
Whenever you do one part, you have to do all the parts. That's that poster right there. Every time you do that, a kitten dies. So. Alrighty, we don't want to do that. Other questions? These are good ones. Sorry, my phone. It's been updating all morning. Everybody okay? I just want to say something out loud, just in case you're working on your quiz and you're wondering, or you're working too fast, you're not really thinking. Notice what I have to the left of all of these little guys? I'm labeling what's the derivative and what isn't. It's kind of labeled all the way down. If you're solving, or if you're trying to find a derivative using limits, remember how at the front board I would always draw that big old arrow saying, because I was saving time and I was just saying, just trust me, it's the limit all the way down. You're supposed to rewrite that going all the way down. Just saying, you're about to take a quiz. You might want to think about that. Oh, no. You do need to rewrite that as you go. You're supposed to. For sure. All right, here we go. Finding an equation of the tangent line to the graph at the given point. This isn't any different than what we've been doing. The only reason that I've thrown it on today's notes is because we've got a trig function here, and yesterday you were supposed to kind of memorize what some of those were. Do you remember what the derivative of tangent is? Good. So let's change it to secant squared x. Now they want an equation that's tangent at this point. So here's our formula for finding the slope, and here's the point that they want that slope at. So what do? Plug in pi over 4, right? In place of x. It's been a while since we've done some of these. Pi over 4, what angle is that? It's a 45. So if you need to draw the triangle, draw the triangle. It's 1, 1, radical 2. Do you remember that? Secant is the reciprocal of cosine. Cosine would be 1 over radical 2, so it's radical 2 over 1. So that pi over 4, it's radical 2, and it looks like we're squaring it. So it's 2. Did we just find a point or a slope, or what did we just find? We just found a slope. Derivative is a fancy word for slope. So we rewrite our problem, or we write the equation. Y minus the y they give us equals the slope we found times x minus the x they give us. And there's your equation. You can just leave it like that. Point slope form. Questions on that one? Okay. Determine the point or points at which the graph of the function has a horizontal tangent line. It is possible this sentence could be read a little differently. The sentence could say, find the tangents for the following. If it's saying find the tangents, it means tell me where it's tangent, or find the horizontal tangents. If it says to find the horizontal tangents, it's like just 4 or 5 words there. This is what it means. Just saying, you might see that soon. Maybe not. Just saying. Determine the points at which the graph of the function has a horizontal tangent line. So what kind of slope are we looking for? 0. So let's find our derivative. What do I do? Quotient rule. Booker T. So bottom times the derivative of the top, which is 2, minus the top times the derivative of the bottom, which is 2x, all over the bottom squared. So that was Booker T minus Taco Bueno. Logan, were you here the day that we did the power rule? That's why you're confused. It's the fast way so you don't have to do limits every time. No wonder you're confused. Yeah, you've got some work to catch up on, is what that means, Logan. I'm sorry. I had a kid first hour do that too. He goes, "Where are you getting that?" And he just kept asking the same question. We were like, "What is your deal?" And we were like, "Oh, you were gone those 2 days. You've been gone for 2 days, so you are completely lost." So I promise this will all make sense later.
Okay.
Sorry. No wonder you're confused. Alrighty, so now we just do the algebra. 2 times x squared is 2x squared. I'm going to distribute the negative and the 2x at the same time, so that we have negative 4x squared and a positive 2x. (2x squared minus 4x squared is negative 2x squared. And we're done, right? Take out an x. Great job. Take out an x. Take out one of the x's. Take out one of the x's. So that we have, the derivative is now negative 2x plus 2 over x cubed. Now we're done, right? You haven't done what they asked for. They said find the points, or find the places, find the horizontal tangents. Meaning, where is this going to equal 0? Multiply both sides by x cubed, and we get negative 2x plus 2 equals 0. Subtract 2 from both sides, and we get negative 2x equals negative 2. Divide both sides by negative 2, and we get x equals 1.
How do we get rid of the...
Multiply both sides by x cubed.
Oh, okay.
Good question. Ocean, you okay? You look unsure. Are you okay? You sure? Okay. So it happens at 1. How do I get the y value? Plug it in here? The original. So when we plug it in, 2 times 1 is 2 minus 1 is 1 over 1 is, so at the point 1, 1 is what we're looking for. At 1, 1, there's a tangent line that's has a slope of 0. It's horizontal. Questions? Are you sure? Great. On the other side, this looks completely scary. It is not a big deal. Promise. If you look at the top row, these are all the different ways to write derivative. You've seen me use y prime. You've also seen this notation, but we usually take our apostrophe and we tuck it in between the f and the x. Both of those are equally the same. Dy over dx, you've only seen that a couple of times, but that just means derivative. So in case you see that in the next 20 minutes, that just means derivative. Just saying, in case you see it again, it means. All right, know that. And then we've got these guys. You haven't seen those much yet. You will see those more and more. All of these mean the same thing. Now notice we have a second row. We've got double prime. What do you think that might mean? It means a second derivative, which is a derivative of the first derivative.
Oh.
And then we have triple prime, which is the derivative of the derivative. Then they quit doing the little apostrophes because nobody wants to count all that, and they say the fourth derivative, fifth derivative, and so on. So those are all the different ways to write those. So for our first example, we have a triple prime. We're looking for the third derivative. So let's find the first one. Y prime, what's the derivative of sine of x? Cosine of x. I love that you have that memorized. Double prime. What's the derivative of cosine of x?
Negative sine x.
And then triple prime. Derivative of negative sine x would be
Negative sine x.
done. See, that's not bad. All right, now we're going to the fifth derivative. Yeah, Nick is not fooled. First derivative. What's the derivative of 2x to the 7th? 14x to the 6th minus 5x to the 4th. Hey, Logan, have you seen kind of the pattern here? Of how to kind of find derivative? That's kind of the big takeaway from that video you missed. Second prime. 14 times 6, anybody know? 84? X to the 5th minus what? 20x cubed. Third derivative. 5 times 84 is going to be 420. X to the 4th minus 60x squared. Fourth derivative. Don't do 4 little tick marks. Just put y to the 4th, and it's got to be in little parentheses. Otherwise, it makes it seem like it's an exponent. 420 times 4 is 1680. X to the 3rd minus 120x. And the fifth derivative is going to be 3 times 1680 is 5040, 5040. X squared minus 120 done. You just found the fifth derivative. See, that's not bad.
So when you do a hard one, I'll actually be in my homework.
It's really not that bad. It doesn't get too crazy. I don't think it asks for like 20th derivative of some crazy quotient. I don't think it does that to you. That would be funny though, for me. Alrighty, your assignment's down here. This is just adding more onto what y'all did yesterday. We will grade that tomorrow, so be ready for that. And third hour, I apologize, you still have not seen your limits test because we ran out of time. We will see that tomorrow, is my plan.